11th week of the semester, and we're still covering MongoDB. Today we'll complete MongoDB, and next week we'll start talking about as a module that allows us to have a consistent API for logging in with various authentication authorities. Right? Not only will we be able to use username and password, but we'll be able to log in also using third-party authentication such as Google or Facebook or any number of authentication. I will use Google, but it's the same exact API that's applicable throughout many providers. We'll use OAuth authentication for using Google, so you'll be able to log in with your Google account and get some basic information from those users. But first, I'd like to complete MongoDB. In particular, the new version of Mongoose, version 4x, supports promises. So they are backward compatible with the previous version, so that they still support callbacks as we've been using, right? When we do a find or save or create, we pass. But version 4 and older and newer support promises. So we can use the same exact API that we've been using on the client side, where we use we return promises, and we have the then and register callback functions in the then clause. We can do the similar API using side. Okay, so I'd like to talk about that a little bit. Also, I'm working on another example that I'd like to run by you. But this one is from scratch. I'll demonstrate for you how to create a project from scratch. It's a Mongoose application, it's an Angular application, it's an entire main stack application, but from scratch. A project, the movie project, but it was being hosted in a larger application, right, which is a portal. This is a portal application, and the portal, the project was just one small piece of it, right? The movie project was just one small piece of it. And because it was a sharing with other experiments and other things that were happening in the application, we had to prepend a lot of the APIs. We had to put it in different directory structures. So I'd like to show you how to do it from scratch, what it would look like. What else? It creates a navigation based on the data model. The data model can drive a little bit some of what are the best practices for navigating certain types of data models. Right? All right. So yeah. So let's talk about Mongo database, Mongoose, in the context of this new application that I've been working on. All right, so I'm gonna close this project, and I'm gonna start another one. It's this one, Web App Maker. So let me start this application. There, so it's an application that it's phone friendly, right? It's phone first, right? So it's designed specifically to be used on a small screen, but with the intention of not making any compromises, right? Ideally, I should be able to do on desktop, right? So to be fairly ambitious, this is an IDE. Right. This is so presumably everything that I can do on WebStorm, I should be able to do on this application. Right. I'm only gotten started. I'm not done, but it's a project that I'd like to run by you. You land here. This is the list of developers, right? That presumably this is an online IDE that can host all numbers of applications, and any developer can be able to create any number of applications, right? So presumably there's a one-to-many relationship between developers and their applications that they create, right? Right now there's no login, so presumably I'm some kind of super user that I can see everybody, all the users, right? And I can navigate through each one of the users and see their details, right? And all their applications and so on and so forth. Over the weekend, I'm going to add passport login, so that it'll be the topic for next week. That I'll be able to log in here, identify myself as one of these developers, and I will only have access to that part, right? I will only be able to see those applications for which I have logged in. Right now, there is no login support, so I start off with all the developers. Make sense? Okay. Then, if I choose a developer, I can drill down and see the applications for this user. Once I know what I want to choose is which application do you want to work with, right? Or do you want to create a brand new application? Right? So there's a one-to-many relationship between the users or the developers and the applications. So you choose one of them, and then you filter on the applications for that one developer. Make sense? Then you might say that applications contain all sorts of artifacts, right? An application might contain client-side artifacts, server-side artifacts, right? If it's on the client, you might have pages and style sheets and images and everything that has to do with front-end development, right? On the server side, you might have web services, you might have data models, you might have all sorts of server-side. To keep it simple, let me turn this off. To keep it simple, I'm going to keep it just on client side, right? Artifacts, and then in only pages, right? So presumably HTML pages. So if I choose an application, it navigates to the applications. Applications are made up of a whole bunch of pages, right? And pages can navigate from one page to the next. And these are all the pages that make up this application. So I can have about pages or hello or home pages and profile pages and search pages and details pages, all sorts of different types of pages that I would add them here. Okay. If I navigate to a particular page, I would see the widgets that are in that page. So a page might contain all sorts of widgets, right? It might contain map widgets, might have table widgets or lists or input fields. It might have YouTube videos, all sorts of different widgets, right? These are some of the more basic types of widgets. Maybe a header widget, that's a pretty simple widget, right? An input field, a paragraph, a label, an image. Those are some of the widgets that are available on a page. I should be able to add new widgets to this page, perhaps reorder, right, and just move the widgets into a different location. These are labels. We have input fields here or buttons. I can type. I can move buttons around. Okay. Each one of these. This is as far as I've gotten. Okay. I'll add more over the weekend. For each one of these. Pages, I can notice that I have a plus on the right-hand side, right, and I have a back, right. So it allows me to navigate as deep as I want, then come back, right, and navigate through another branch. It allows me to navigate the entire data structure, right, following this kind of branching mechanism where I can start from some kind of root, right, and then navigate by choosing any one of these branches. Right. Notice that each page is very standard. having a back button to go back. It has a plus button to add more of the instances of each one of these types of entities. So if I'm in the page, I can add a page. Or if I'm in an application, I can add an application. If I'm in the users, and developers, I can add a developer. Right. So to add a developer, I click plus, and there's a dedicated page that allows me to create a new instance of whatever it is that I'm in. Right. If I'm in a developer, I would have a new developer page. If I'm in an application, I would have a new application page. If I'm in pages, a new page, and so on and so forth. Okay. I can create a new developer. So let's see, or I can cancel. I can go back. So I have A, B, C. So I can create Dan. And notice that there's an OK button to dismiss and say, yes, save this. It goes back, and the normal navigation is that I'm done. It gets dismissed, right? And it goes back to the list where it shows the new element that I've added at the end, at the bottom. Okay? So no new dialogue. It's not, I'm not creating a new dialogue. It navigates to a dedicated page. If I click on an info button, or this might be a gear or an edit button, some kind of pencil maybe, I can go back and update that particular entity. So there's two dedicated. The editing and the creation, they could be reused. I could reuse the same page for two different things, one for creation, one for editing, but not necessarily they have to have the same exact user interface. The editing might have more involved things, right? So the creation might have just maybe a username and a first name and a last name for the person, but an editing might have more things, maybe and all sorts of things for that developer. So these two pages not necessarily need to be the same, right? Plus, this one might add additional attributes such as additional actions such as delete. This will allow me to delete the element from here, or update. This is Dan, sorry. Daniel. Updated. Once gets updated, it goes back to the original page. So notice that the navigation is very, very the same, right? It's consistent all throughout, right? If I go to an application, same thing. I can create an application, right? Consistent. I can go and edit, although I forgot to put an OK button, right, to save. But if I saved it, it would go back to the application. Very, very consistent. Go to application, same thing. I can create a page. I can create a home page. I can create a profile page. I can create a search page, and so forth. Okay. Then notice that the creation really only creates some meta information, not the actual content of the page, but meta information about the page, right? So I can go back to the home and there's no I can edit the name of the page or change the title, or I can navigate to a page and have the widgets. On the widgets, I changed these icons a little bit. Also, if you hover, it tells you which one you are on, so that it gives you a hint on what is that you're on the plus here on the ad. I took a different approach on the ad. This goes maybe to a list of the widgets that are available. It could have been maybe a select box, but I prefer to have it as a long scrollable list of widgets that you can select. Here I have a header, labels, text input. So these are very common HTML widgets, right? That are supported, but it could be as sophisticated as you want it, right? It could be a YouTube video, right? It could be an image, it could be an iframe, it could be whatever you want. It could be any compounded, templates. It could be a very sophisticated template. It could be a data table, right? And the data table, you can point it to a web service URL, right? And the web service URL, it downloads JSON objects, right? A JSON array, and then iterates over that array and displays a table, right? It could be a fairly complex widget. It could be the widget. Each widget could be as complex as you want, right? When you add the widget, it adds it at the bottom. It adds it at the bottom of the page. There it is, the new button that was just added. Right? It adds at the bottom, but then you can reposition and put it wherever you want. Okay. Each widget, if you click on the edit, it would have its own editor, right? So buttons, you should be able to change the label. Maybe if you want a blue, red, green, yellow. If it's a header, then it have a different editor, right? We'll have the size of the header, right? 1, 2, 3, over to 6, maybe the text. If it's a paragraph, right? You should be able to copy and paste maybe content in there in the paragraph. Just a page builder, right? You could get more sophisticated. If this were a bigger screen, some of the widgets could be layout widgets. Like you could use bootstrap grids, right? You could create rows and columns, right? And you can split the columns any which way you want. And then each one of those would be a container where you can put other widgets inside, right? As you want, right? But I'm not gonna go in there, right? Because again, I'm focusing more on the mobile. On mobiles, typically you're not gonna have 2, 3, 4, 5 columns, right? Usually it's just one single column. But it's not far-fetched that you could add things like that. Yes, right. So this is as far as I've gotten. Right now, each one of them has a default text value. They all say text. This is headings, right? So I'd like to just share with you how this was built. But before we go into that, I'd like to share with you a little bit what the data model looks like, and what the overarching design is. Okay. So let me go here and stop sharing. So the data model looks something like this. Right, where you have a user class, right, and actually no, a developer class, right, and each developer class has 0 or more applications, right? If you want to make it more sophisticated, where you might have many application, right, you could go a little further and maybe make a mapping table where you could have many developers are working on the same application, right? That could be more interesting, right? But right now I'm just going to take this happy path over here. One developer has many applications. Each application has many pages, right? Right, and has many widgets. And there are many types of widgets, right? There are, right, so you can have a specialization here where you can have any number of widgets down here, right? So you could have a heading widget, right? You can have a label widget. You can have a paragraph widget, right? A button widget, a link widget. You can have a YouTube widget, right? You can have a Google Maps widget. So any number of widgets that you might add here, right? They might have certain features that are shared amongst all widgets, right? But then you have the specific things, right? So each widget can have a name. You can have the order, the position where it's located on, right? Might have an ID, a class. Right? Might have certain things that are shared amongst all of them, right? Maybe some of the some styling that is common, such as absolute the position, right? Any styling, left, top, right, or things like that, right? That are common to everybody. But then each one would have specific things. Have the ID of the YouTube video or the URL if you want to go and visit the URL of the YouTube video. and so on and so forth. Okay, make sense? So right now, there's as far as I've gotten. There are two types of users. So you might have here the developer is the person who has access to edit, right, the entire data model. But you might have a different user, the user who uses your application, right? That user can run your application, right? Can use your application, fill out the forms, click on buttons and links, and navigate through your application, but they can't edit your application, right? They can't move buttons around. They can't remove widgets or pages. They can navigate between pages, but they can't edit those pages, right? They might share things that are in common here. So this is a person, and you have these are special cases of these two. As they interact with the application, they will be submitting data, right? They will be submitting forms and filling out input fields. This data needs to be stored somewhere, right? Well, I can't store them here, right? Because this input fields. These are what? These widgets are only used for rendering, right? For rendering the page. They're not used to storing any data, right? But somewhere we need to store that data. So we'll need at some point some place where there's a data table that says that so and so person using so and so, right, filled in provided data for a particular widget. You know, as they were interacting with a widget, maybe an input field or a text area or drop down or whatever, right? When they submitted it, right, we're going to keep track that this particular user for that, you know, using that particular application provided this particular data. It's going to be a very denormalized, right? It's going to be very denormalized, right? Because we don't have a data model for this. There is no data model, right? The data model is a page. That's as far as we can determine that that we have a data for the page, right? All right, we'll get to that a little later. So to do this, we can use Mongoose. We can use Mongoose, right? To do this data over here, we cannot use Mongoose because it's going to be a denormalized schema. Right? Well, there's not going to be any schema, and we're just going to have to capture data as we go, right? And so we can use other less restrictive, more native MongoDB libraries such as MongoJS. There's some other libraries that allow you to interact with MongoDB, but they are less restrictive, right? They don't do any validation. You can create schemas as you want, right? So you know, using some of the benefits of MongoDB, allowing these elastic schemas, right? The schemas that can change over time, right? This is a great. You would want something like that, right? This is you know, this has been modified. The pages, I don't know the page. Somebody can edit the page, right? And so the data model needs to change when I store the data, right? So we'll talk about that when we get there. All right. All right. So I'd like to show you the implementation of the application. Let me move that. And so the whole code base is available in my GitHub. You go to Janunzi and go to Web App Maker. It's a Janunzi Web App Maker. You'll notice that there's 153 commits, right? I've made a big effort to make those commits small, right, and easy to follow. You know, that they should be useful as if they were slides. Okay, as we connect the dots between the client, talking to the server, talking to the database, and back, right? Each one of these commits should be an incremental step at implementing this application, right? Before we start looking at that, I'd like to draw for you a little bit what the architecture of what is it that we're building. Okay, so let me go back and share and turn off screen sharing again. So the basic architecture of what we're building is something like this. Right. So we have the user here, okay, interacting with HTML. I'm doing it small because I don't have that much space here. I guess I could bring this up a little bit. So yeah, so we have the user here interacting with the browser. So here's the browser, HTML that is being rendered by the browser, right? And as they interact with the HTML, right? And the controller's only responsibility is to handle these events, right? There's a stream of events that are being generated by the user as they click and submit and move things around. And the controller is only responsible for handling those events. It's the interface between user movements or user gestures, right? It's the interface between user gestures, right, and the data model, right, the data. It's not responsible for updating the data, but it is responsible of knowing who's responsible, right? So the controller knows that the services are responsible for manipulating the data, right? So the services, again, are interfaces between two worlds. So there's a lot of interfaces here, right? The HTML is the interface between the user, right, rendering things for the user and accepting direct manipulation. Those are generated as events that are handled by the controller. The controller then represents them in some strict JSON or data model, right? Which is then passed on to the service, and the service is again an interface between two worlds, between the object world represented here in the data model by the controller, and some other world, the HTTP world. The HTTP world, right? It sends it over over the wire to a server. Right, and the server has another interface here. It's the web service that is the mirror image of the web service, of this client web service. Right, this sends the HTTP, whereas this one receives the HTTP. Right, and does the backwards conversion back from HTTP back to the object world. Yes, right. This one is not responsible for manipulating the data, but it is responsible of converting the HTTP to some object representation, which then gets sent over to the model, right? And the model its task is to convert that object world into a data world, into a permanent storage representation, which is the uses Mongoose to do that. Mongoose, which then sends it to the database. Right, so this is the server here. Right, and between here and here, there's another network connection. Okay, so these are two network connections. These are two network connections. Mongoose is the interface between a high-level API, right, and a low-level API that talks to the database. Right, it provides a low-level API to talk to the database, whereas the model, our model, provides a high-level API to the data model. Right, it provides a nice interface. You know, create user, remove user, create application, remove applications, add widgets, add pages, remove pages. Right, that's a high-level API. This one it converts it into low-level, insertions and deletions and updates into a database. Make sense? Right, so this makes it this hides the fact that we are using Mongoose to talk to the database. This API could stay the same, and we all of a sudden decide that we want to store things in a file, in XML, right? And this API would still be the same for everybody else. You see that? So that's right. And using, well, sometimes these are referred to as data access objects. Data access objects that that hide the details of how it's being stored. Make sense? Right. Each one has its own work. So these two are network connections. And because of that, the single thread that this Node.js is running with a single thread, right? So here's Node.js, right? As a single thread, and when it tells Mongoose to make the database insertion or update or deletion, this could take a while, right? So Node.js cannot stay and wait for this to complete, right? It cannot wait for it to complete because it has lots of things to do, right? There's a whole bunch of other browsers out here, right, that are making also a whole bunch of network connections, right? And anytime that this thread is busy, all these HTTP requests are being queued up, right? And they're all waiting for, each browser is waiting for a response, right? So the thread can't stop here. So instead, what it does is that it starts another thread that is responsible for listening and waiting for the response to come back. And so it's free to come back and listen for other incoming requests. Right? So you have to be careful that these function calls, you have to understand that these function calls are not synchronous function calls. Assume that what's going to come back is the data you would expect. Instead, what you get back, right, is what we call promises, right? Promises that are just objects that allow us to register for a future response, right? That allows us to register a function saying, hey, at some point, please let me know, right, when you get the response back, right? I know it's different than the way we are used to programming. We're used to programming that you call a function and the function comes back with a value, right? This is the way we've been learning how to program, since we were teenagers, right? And you make a call and the call comes back with a value, right? Well, this is not so. These calls, they come back with a promise of later on at some point calling you back, right? So that you can go off and do other things. And when the callback comes back, it'll interrupt you and say, hey, here's what you asked me to do. Here it is, right? So it's very different to think about synchronous programming and this asynchronous where you have multiple processes running on their own schedule, right? And they notify each other. Right? So in this one too, this happens as well, right? This one is also a network connection. So here too, we have a single thread running on the browser, and we cannot tie up that single thread, right? We can't tie up that single thread. If we tie it up, all our animations and our forms, and as the user clicks and things, is waiting over here. We can't do that. So what happens is that this call, when we call the HTTP service on Angular, it's also an asynchronous call. It uses AJAX to, the browser's AJAX support to go off and listen and wait for a response while liberating the single thread to go do something else. So what happens here is that the model registers with Mongo to come back with a response, Mongo in a callback. This one, it registers with the model for a callback, right? It comes back with a callback, and eventually, at some point, finally, we respond with a response. So this is a request goes in, and then a response goes back to the client. Again, here we had register a callback for this to come back. It calls it when it comes back successfully or with an error, and then it goes back, and then we're ready to update our model, and the model updates the UI. Make sense? All right. I wanted to go over that because I saw some of you were treating some of these calls as if they were synchronous when they're not synchronous, right? And I just wanted to go over that. All right, so let's go look at the commits. Any questions? Make sense? All right, so let's take a look at this. All right, so I'm going to go to the very and let's go through this. A lot of this we've seen already, so I'm going to breeze through some of this. Right, I'm going to skip through a lot of this because you should already be familiar with. But if you feel that you want to go over something, please stop me. Right, and we could go over it again. So it's a brand new application, right? And the very first thing that I create is an ignore file and put in there files that I want ignored. Certainly, I don't want anything with the IDE and the node modules either. Also, I create a very simple server. Why is it showing it this way? Wait a minute. Unifying. Yeah, there we go. So a very simple server that listens as 3000. You need to install Express, right? So you'll install npm install Express. We know that already. What is going on? Okay. Package. You need a package.json, right? This will allow other people to clone your project, do an npm install, and right away start using your project and play around and participate in that project. To get a first version of this package.json file, you can do an npm. And it'll ask you about who the author is and your contact information and a small description of the project. Okay, and then every time you install a package, don't forget to do npm install the package and then -- save. Right, -- save will update package.json and add any dependencies here. In this particular case, I had forgotten to install Express, so I installed it again. It said npm install Express -- save, and it add that dependency right here. Okay. I also installed the mongoose dependency. So I just said npm install mongoose -- save, right, and install it locally and added the entry in my package.json. And notice that we're using one of the latest versions of mongoose. So this version support promises. First, we'll look at the classical way of doing it using callbacks, and hopefully we'll have a chance to take a look at the new promise API that Mongoose supports. So first, I focus on the schema for the developer that develops applications. So here we just have a username, password, email, first name, and last name. I overrode the collection that I'm going to use for storing this data, right? And so I don't like the default name that Mongoose chooses. So I chose developer. Also notice where this file exists. This is my first piece of code, right? Notice where it lives. It lives in the app directory. See that? It lives in the app directory. So at the root of my project, I have an app directory, right? And in that app directory, I'm going to put all my server-side code is going to live there, right? Instead of in your assignments and in your project, I've asked you to instead put it in your public directory, yes, under project, under server, yes, and that's fine for an academic environment, right, where your TAs and your instructor want to have public access to your files, right? They want to have certainly public access to your client-side files, obviously, but also public access to your server-side source code. Okay, but on a production environment, in a development environment, in a real development environment, you would not make available your source code, especially your server-side code, where you have a lot of business logic, right? You might have a lot of proprietary information that you don't want to make publicly available, right? So all the source code that is server-side, notice that it's not in the public directory, right? It's in a separate, unaccessible directory that is not publicly available. So it's under app. Under there, I can have everything else, models and services and whatnot. Yes. Also notice that under this is a schema, so it lives under the models directory. Yes. But notice that I put it in a dedicated developer directory. See that? In your assignments, I've asked you to put, I believe, all your models under the same directory, under the models directory. And that's fine when you have few models, a few schemas, right? Which I think we just have 2 or 3, right? But as your project grows, right, it's very common that you want to split that up, right, and have dedicated directories to organize your an ever-growing number of models, right? We can have a dedicated directories for that. Again, whatever works for your particular application. Once you choose a directory structure and the whole team agrees, it's good that everybody sticks to it, right? So that it makes it easier for the rest of the team to to become familiar with the application, files to be, right? It makes it the whole productivity of the team the whole team becomes much more productive as you put things where they should be. Also notice that we are loading Mongoose. We're loading Mongoose right here. We're not passing it to it like we did for the app in our assignments, right? In our assignments, we instantiated Mongoose, a top-level app.js, right? Remember that? And then we would pass around the instance of Mongoose, right? Instead here, I chose to just load the Mongoose instance library so I can use it here for defining the schema. That's fine, right? There's a more common way. We load Mongoose on demand, right? And then we use it just to declare instances of this. Okay, now that we have the schema, we can create the model. We can get started with the model. It's in the same developer directory. It's in the same developer directory, and it just loads the schema. Which we've just created, right? And then it creates the model from that schema, right? And that's all it does. Here, it loaded Mongoose on demand, right? So to be able to instantiate the model, right? Again, notice that this is inside of a developer.model server, and it's creating a Mongoose model, right? It's creating a developer Mongoose model. So there's 2 models, right? This one, the developer.model.server is what? It's the high-level model, right? It creates a consistent API, a high-level API for the rest of the application. Yes? But internally, it implements the nitty-gritty and raw low-level, uses the low-level APIs to talk to the database through this developer, through this level model, Mongoose model. So I'll refer to these as the Mongoose model, and I'll refer to the other one as just the model. Okay? But there's 2 models. One is low level to talk to the database, and the other is a high level. It's just very much like in Java or C#, when you're creating data access objects, same thing. The data access object creates an API for the rest of the application to have ABC or entity framework, right? To actually talk to low-level database. Make sense? Right? Okay. All right, so let's connect to Mongoose, to the database. So to connect to the database, same thing, right? We require Mongoose. We do a mongoose.connect. Now, I'm only connected to a local database. I have not added a code here to be friendly with OpenShift, right? So I've not done any OpenShift development. So this project can only be run locally, right? Although you can certainly add OpenShift compatibility, but right now it's only executable locally with the local database called Web App Maker. Yes? All right. So if you want to clone this and play around with it locally, you'll need to start MongoDB, right? You'll expect MongoDB to be already running, right? Okay, so here's my first. This is the entry point, right? This is the entry point to the rest of the server application, right? App.js, right? And app.js might need the connection object. So I'm going to pass it the connection object to the rest of the application. Although I haven't had a need for the database for the database object, but I'm passing it nevertheless. In my server.js, I'm going to require my app.js. Notice where it lives. It lives at the root of my project, right? App, and under there, app.js. And it's in Node.js, a module that I'm passing the database connection. In that app.js, we're going to load the model. There it is. I'm going to load the model, which we created a couple of slides ago, right? We created the model that loads the schema. Meanwhile, as we instantiate the model, we're going to pass the connection. So notice that the Mongoose instance, we're not passing it around, right? But the database connection here, this one is not meant to be created and destroyed and created and destroyed. It's a very expensive object, right? It's a very expensive resource, right, to be creating and destroying on demand. Okay. Typically, servers can be configured to maintain a pool of connections, right? Connections are so expensive, right, that ideally you want to you want to create them only once, right? And typically they can be created at boot time, where the server boots up, right? Creates a pool of connections, right? And then it shares these connections in a connection pool, right? And so any thread that might need to connect to the database can ask for a database connection from this pool, right? It uses this connection. When it's done, instead of closing the connection, it just releases it. And goes back to this pool so that other threads that are around might ask from this pool, right? Some servers can be configured to throttle, right? And as traffic grows, right, the server can be configured to ask for more connections, right? If there's no more connections in the pool, right, it can be configured to ask for 10 more connections, right? Instantiate 10 more connections and have them around in the pool. If towards the end of the night and it becomes idle, it can throttle back down and just release those connections as time goes by. Right? So some servers can be configured to have these advanced throttling and resource management as the day goes by to manage how busy the server is. Right? We're not going to do any of that, right? But just so you know, just not to throw away that database connection. It's very expensive. All right, so we have the model. We passed it around. Load the development. We did this, right? Oh yeah, we just did that. Okay, so in the model, we're going to create our first high-level API, right? That we need to implement to create a developer, right? So here's the API. It's going to be implemented below. Again, this is following John Pappas's style guide, right, where we declare our API way at the top, right, and down below we implement the actual implementation of these functions. And internally, we want to use the developer low-level Mongoose developer model, right, to actually do an insert into a database. And there's a typo here, right? It's not save, right? It's create.create, right, which I'm going to fix in the upcoming commit. Right, but the call is correct, right? We pass the object. This object is going to be validated against the schema, right? So this object better have all the, well, not all of them, at least a subset of the fields that were declared in the schema. So the schema said that we're expecting a username, a password, a first name, last name, all the things, right? Right. It doesn't have to have all of them, right? But those that are there should be a subset of that. Any other field that is not in the schema will be ignored, right? Or fields that are of the wrong data type will be ignored. Okay, right? This is still using the legacy API where you can pass around a callback, right? So we can register the callback right here. Okay. And following this this way of doing it, when you have to do many synchronous calls, right, you end up with code that is that's nested with a lot of callbacks, passing another callback, passing another callback, passing another callback. You get this code that is very like a pyramid, like a pyramid on its side, right? Which they came up with the promises API, right? Which is exactly the same thing. You're still using callbacks, but they're not registered here. They're registered upstream. Instead of doing it here in the model, right, you tell the service to register, not me. And so that's what we're going to see a little later. Version 4 of Mongoose now also supports promises. We're going to use the default implementation of their promise API. Although you can plug in your own Mongoose, your own promise API. You can choose. There's several competing promise APIs out there, right? And we're going to use the default one, right? But not now. So we could register here, or we can register with an object that this returns, that the service registers, right? Okay. So there we go. So again, when this function happens, when this function is called, and this executes, when this executes, the thread is not going to wait for this function to complete. It just makes the invocation and it keeps going. It's not going to wait for this function to come back, right? It might take several seconds for this to execute. The thread is not, it doesn't have the luxury of waiting 10 seconds for this to come back. So it makes an asynchronous call and just passes by. All right? Goes back on listening for incoming requests. Oh yeah, I had a syntax error. I have module, so I fixed it. Okay, so the web service. So the web service is going to listen. From the client. Is going to receive posts, right? The client is going to pass the information about the new developer, right? Their first name, last name, register, right? And it's going to map it's going to map to a local event handler, right? And it is an HTTP event handler. And the event handler, is going to use. I'm sorry. It's going to use the model in a minute. But before we get there, let's tie this. Let's load that service, which I had a typo. Let's load the service from the app.js, the root app.js. Here's the service. And we're going to load the model, both of them, and going to pass the model to the service because it is the service who's going to use the high-level API model, right, to then have it call the low-level Mongoose, right? So here we're passing around the app so that it can use Express to create the URLs, and it passes the model so it can talk to the database. So the web service, here's the web service. It's going to receive the incoming post, and is going to call this function, and it's going to have to parse the JSON representation from the body, right? Now it has the developer representation, and it's going to use the model to create the developer. So it's going to and then what happens after this function call? It just comes back, right? Has the developer been added to the database? I don't know. Maybe, right? By the time the function comes back, the developer might not be in the database just yet, right? It might take a while. Remember, the thread does not wait for this function to come back, right? This function comes back. This function comes. I'm sorry. Wait a minute. Oh, this should be create developer, not just create. Right? It calls create developer, passes the developer. It does not wait for it to come back. For this body to work, we need to install body parser, right, and multer, right? So you have to do an npm parser and npm install multer -- save. Don't forget. Okay, so yeah, so here's where we load body parser and multer, and but that's not enough. Just loading the libraries. That's not enough. You also have to configure them. You have to turn on body parser, JSON parser. Right? You have to turn it on by calling JSON, and also saying that the data will be URL encoded. Right? So you need to go through those 4 lines, right? And I've seen some posts on Kansa saying, I installed body parser, but it's still not, the body's still. Why? It's because maybe you missed those other 2 lines. Okay, that you need to turn on body parsing. Okay, and that's fully documented in the Express.js documentation, right? So don't forget these 4 lines of code. Also, the require app.js needs to happen afterwards. It needs to happen after parser is turned on. Okay, otherwise it will not parse the body. Right? So notice that I did that, right? I moved it from above, I moved it down below, right? Because it wasn't working for me. All right. Again, this is from scratch. Right? Downloading. Okay, I downloaded an Angular and routing, so I'm not going to cover that. I installed jQuery and Bootstrap. I declare Angular application. So here's my developer controller, my first controller. So this controller. So here's my first page that I created, developer list. So this is the page that allows me to just list all the developers. It's this first page right here, the list of developers, right? So there's got to be 3 HTML template files for each entity. Right, so my entities are what? The developer, applications, pages, and widgets, right? And so I'm going to have, for each one of them, I'm going to have a list of the developers. I'm going to have a new developer, and I can edit a developer. So those are the 3 operations that I can do with each entity, right? So I'm going to have my first page. This one is called developer-list.html. .view.html, and then I'm going to have a developer-new.view.html, and then a developer-edit.view.html. Notice that I'm following a naming convention, right? Again, naming conventions make it easier for everybody else. But I understand the pattern, right? If they need to create new entities and they need to create, right, and follow this pattern. Once you identify a pattern, it's good to just stick to that pattern, right? So that everybody increases the productivity of the whole team. So I'm going to create a developer list controller, and the controller is somewhere down here. Here's the controller. Notice where I'm putting the controller and the view. They both live under the developer directory, right? So all my views are going to live here. My 3 templates, plus the controls are going to live here. Okay. And my controller here, there it is, developer list controller. And right now it's just using VM equal this. Another thing for the so up to this point, I believe from in the assignments I haven't asked you to use model. Have I? I don't believe so. It's in the requirements to use model. Oh, never mind. It wasn't in the rubric, and you weren't losing points if you didn't. But in the next, it is definitely in the next rubric. So make sure that you are using model and controller as and all those good practices. Okay. Yeah. So that's part of this, right? Of declaring the view model and linking it to the controller. Added bootstrap glyphicons. Okay, so the new developer page, what I want to be able to do is that if I click on plus, it navigates to this new developer page, right? So to do that, in my I created a button that links to developer new and loads the developer new view. Okay, and in that page, in the what I did is to create that button, this button over here, I added this plus glyphicon on the right-hand side. I did a pull right that pushes the link to the right-hand side. And on the new developer, I added a button to go back to the developers. Notice that it's the slash developer goes back to the navigates back to the developer. Either one, both of them actually navigate to the developer. So it's these two buttons, right? This one definitely cancels and goes back. This one also goes back to the developer list, but this needs to do something before it gets back to the developer. It needs to add the developer to the model. Which is not yet implemented. So I, at first, just to test the navigation, right? I just point them back, right? Created input fields for each one of the fields model, the username, the email, first name, last name, and so forth. I created a controller. Now the controller for the developer new. Right, so here's the controller, the new developer controller. Notice that they live in the same JavaScript file. You see that? Right, up to this point, right, in many of the other projects that we've seen, we have followed the pattern of each template has a dedicated JavaScript file. Okay, and that's definitely you know, the appropriate way of doing it, especially if your controllers are fairly complex and have a lot of buttons and a lot of event handlers and a lot of using a lot of web services to communicate. Right, we're following 3 templates, 1 JavaScript controller file, and then the 3 controllers in there. Right, following that pattern. Right. So here, notice that we have 2 .controller. See that? Declaring 2 controllers in the same JavaScript file. Again, if your controls are fairly simple, this is good enough, right? But if it starts getting if your controls start getting fairly complex with lots of communicating with lots of web, services and whatnot, then a better approach is to split them up into individual controllers. Okay, and notice that each entity for me is going to be 4 files, 3 views. 1 JavaScript controller file, right? If your starts getting fairly sophisticated, where you have lots and lots of templates, right? Then you might consider creating subdirectories under there, right? 1 for the new, 1 for the list, 1 for view, 1 for whatever, right? Every time you start getting more and more, 4, 5, 6, 10 files, it starts getting out of hand, right? So you start considering organizing it into groups. So my new developer controller right now is just it's going to handle an event handler when you create that OK button, right? To store that new developer. So in the in the OK button, right? I'm going to add an event handler that calls create developer, and it passes the developer instance. The controller is going to delegate to the I declare the new developer in the config, but it's going to delegate the actual creation of the developer to the web client service, right? The client service is going to delegate to the web service. The web service is going to delegate to the model, and the model is going to delegate to Mongoose, right? Remember the architecture that we're following, right? So I load my client service. Here it is. It creates the first high-level API, right? The create developer, and it returns the API so that everybody can call this service. And right now, the only thing that it does is it just echoes the developer that the controller passes. The controller, in turn, the create developer event handler is going to use the client service that we inject, right, so that it can call the developer. Again, this is not going to be a synchronous call. It looks like a synchronous call, but it's not, right? Remember, asynchronous, right? So we're going to have to come back here and refactor this and add the then clause, right? The database finally, when it receives it, it's going to take the developer object, validate it against our schema, and notice that I fixed this, right? It wasn't save, it was create, right? Create inserts into a database. The web service, I also renamed it correctly, right? Create developer as opposed to just create. It uses the server, the model, right? Oh, okay, so we can read this correctly, right? Let's create this from, let's read this from the controller side. So this is a better read, right? From left to right. We're going to go to the client service. From the client service, we're going to go to the web service. From the web service, we're going to the model. The model is going to go to Mongoose, right? So here's the controller. This is where everything starts. You click on the OK button. This event handler gets invoked. It calls this function on the client service, which is going to respond immediately with a promise, right? It's not going to wait for this function to come back, right? So the client service is going to do a post, right? Using the HTTP service, it's going to do a post. Again, this post is not going to wait for the post to come back, right? It's going to return a promise, right? And I'm sorry, the HTTP service is the AJAX, right? But the thread, right? The single JavaScript thread is not going to wait for this function to come back. Immediately returns an object. This post function does not wait for the post to come back. AJAX is waiting for the post to come back. Instead, it returns an object. That the controller uses, right, to register two functions, right? One is going to be called if the post is successful, and the other one if the post is not successful. There's an error. Okay, so this object that this returns has a function called and that allows you to register your functions. Alternatively, we could have passed in a callback here, right? Like we did early on. We passed a callback, and we could have done HTTP post.success, right? Right. So that's the same thing. It's the same exact thing, right? It means .post returns an object that has a .success, right? That then allows you to provide a callback function. It's the same thing. But instead of doing it here, we're returning the object. We're returning the object to whoever called us, and then we could have done a .success here. We could have done just a .success, right? But that's not standard. That's not standard. The .then is standard, right? Well, as standard you can be with JavaScript. It allows you to pass two functions, one for success and one for error. Anyway, the web service, right? Here's the web service. There it is, right? It is listening for the incoming post. The post calls the create developer. The create developer calls the model create developer. Again, we're going to have to come back to this, right? Because this is not a synchronous call. This makes it to the create developer, which creates and inserts the value. Again, this function is not synchronous, right? It's asynchronous, so we don't have to come back and add promises to this, right? So let's add the promises. Let's add the promises. So the server, on the server, we're going to use Q, right? This is a very common promise library. There's a whole bunch of them. This is just one of them, but it's very, very common promise library that uses a very common API. So the way it works, we create a deferred. So around the model asynchronous call, we sandwich that on either side with a creation of the defer and return the promise. So the object that is returned is going to be used by the web service, right, to register those two functions. So this object that is being returned, this promise object, contains a function called then that allows you to provide the two functions that will be invoked, right? When are they invoked? Well, when the callback of the Mongoose model comes back. When it comes back, we either are going to call the success or we're going to call the error function. If we call the resolve on the deferred object, then the success function gets called. If we call the reject function, then the error function gets called. That make sense? Everybody okay with that? Yes? Okay. Let's see, anything else here? Okay, so notice that the web service, the success function, what's it doing? It's responding to the client. All this time, the post request is live, right? It's queued up, right? The Node.js server has it as an unresolved response. The server, the Node.js server, hey, knows that it has not yet responded to this request. Okay, it's still waiting, right? It's waiting, and not until we use either response JSON or we do a response send. Not until we do that does the Node.js actually send back a response to the browser, right? But the Node.js thread was not waiting here, right? Idle, waiting for the callback from the database, right? It was handling other requests, right? But here it's going to be interrupted, right? While it was trying to do callback right here, it's going to stop doing what it's doing, right? It's going to come back here, the thread, and finally it says, oh yeah, I remember I had that request that had not been yet fulfilled. Now I get to fulfill it. Okay? When the database came back, resolve my promise, finally this function gets called, finally I can send back a response with the developer object. Okay? I had to install the Q library, so npm install Q -- save, right? Okay, so here's another call, another database call. We're going to add to the when a new developer is created, it navigates back to the list of developers. So here, I have to go fetch the list of developers. I just created one. I need to go fetch them. Right? I need to go fetch the new developers. So let's implement in the controller, in the developer list controller, right? In the controller for the list view, right? We're going to create an init function that gets invoked when the controller gets created, and it's going to call on the service find all developers, right? So on the service, we're going to add that find all developers, and right now it's just going to do a console, right? Okay, so what I tried to do in these commits is to show how each one of the blocks, right, from left to right, they're connected, from one to the next, right? So the controllers connect to the service connect to the web service is going to connect it to the model to Mongoose, and then coming back, right? So that's what I try to do. Hopefully, it's easy for you to follow along. So first, the controller calls the client service, right? That's it. Now, the client service is going to call the web service, right? So here we have the client service. The client service is going to use HTTP GET, right, to go fetch all the developers. Notice how the APIs are nice and clean and simple, right? /API / the entity that I want, okay? As opposed to the way we did the project a couple of weeks ago for the OMDB project, yes, that we're working on. If you remember, I had to prepend API / project / OMDB / something or other, right? That was because I needed that naming namespaces because I had a lot of projects, right? A lot of examples and exercises and whatnot. So, but here I'm not competing with other URLs, right? I own all the URLs, right? I'm free to choose whatever URLs I want. Anyway, the developer client talks to the web service. The web service is going to listen for that incoming URL pattern and is going to call find all developers. Okay, that's it. So I connected now the client with the server. Now let's connect the web service with the model. So here's a web service. It's going to use the developer model and call find all developers. Notice that I've used find all developers, the name of the function. I've been very consistent with my naming convention, right? In the controllers called find all developers. In the client service called find all developers. Service is called find all developers, and the model is called find all developers, right? This makes it easier, right, to follow the path of who's calling what, right? To understand that somehow these are all related to one another, right? So try to stick to naming conventions that make it easier for the team, your teammates, to read your code and understand how these things are connected to one another. Yes. So in the model again is going to declare an API at the top, same name, find all developers, and it's just going to print out that it got to the model. Also notice that these baby steps not only are they good for academic purposes on how you consume this. It's also a good development practice, right? That at each baby step, right, I can test each individual one of these, right? Whether I got to the next piece of it. You do an interface. You should test it right away. Don't do lots and lots of code, right? And then let me try it, see if it works at first, right? Usually it's less productive. You're gonna spend more time trying to debug what's wrong with what I did. Do baby steps. Test that little piece of it, and then move on. Okay, so now that we are at the model, finally we use the developer.finds, right? We use the low-level Mongoose model, right, to do a find, and the find has no predicate. That means that it's going to retrieve all the developers, and it's going to return it right here. Notice that we're not going to do a return. We're not going to do a return, right? This is the common way that you code using synchronous calls, right? Usually we've been learning how to program using a single-threaded environment, right? Where we own the single thread, right? We have and when we do a function call, typically that function returns with something. Notice that there's no return here, right? We are not returning. This could be misread and misinterpreted as find all developers. The typical interpretation is that it returns the developers, right? That's a common way we think about this. It's a function, find all developers. Well, the expectation is that it would come back with a list of developers, but it doesn't. because these are asynchronous calls, right? These are all asynchronous calls. So we have the developers, and never will you see here that it says return developers, right? Which is very unintuitive, you know, especially the way learning how to program all these years. Instead of returning the developers, it's going to return a promise that at some point later on, I will pass you the developers when I have them. I don't have them yet. Right? I don't have anything to give you, right? But I don't want to keep you waiting, right? So that you can be free to go about your business. So the model is going to return a promise, and the web service is going to get ready. It says, oh, okay, I know I'm not going to receive the developers from this function call, from this function. Instead, I know I'm going to receive instead a promise for later, right? So I'm going to get ready and with a then. So this promise object has a then function right here. So finally, the mongoose, low-level mongoose, if there's no error, we're going to resolve the promise. We're going to say, 10 seconds later, the database came back, and we can now notify anybody who register a function with us. We're going to notify them. How do we notify them? We're going to resolve that promise. That object we created earlier, we're going to resolve it, right? And we're going to resolve it and pass anybody who had registered with us. We're going to pass the data that we now have. A couple of milliseconds later, so the web service did register with us. Did register a function call and said, hey, I know you got a promise. You're gonna send me a promise. Okay, whenever you get to it, when you do get to it at some point, call me back, right, and pass me that data. So there it is. So that when you do pass me the data in that function call, I can finally resolve and send back the response back to the client. Okay. Right. Otherwise, if instead the mongoose model, if there was an error instead, right? If there was no error, we're going to resolve it. If there was an error instead, we're going to reject the promise. We're going to say, sorry, there was an error. Instead of passing you the developers, I'm going to pass you the error object that came back from the database. The service gets ready and says, oh, okay, so I'll register two functions. One of them, if it's successful, you're going to pass me the developers. The other one is going to be called if it's rejected instead, right? And it's going to pass me that error object, and I have to notify the client. I'm going to notify the client that there was an error. Something went wrong, right? So I'm going to set the status, the HTTP status, to 400 or whatever status you choose to send, right? And then we send the error, right? The controller is going to need to, handle these errors, right? Maybe notify them and provide an alert, some kind of alert at the top, right? We'll do that next, I believe. Right. So the client service, right? The client service is the one who generated this HTTP call, right? And here too, because there's a network connection, the single thread can't wait for this post to come back, right? So instead, it returns immediately. This return, it returns again. It returns a promise. It returns a promise which the controller is going to register for two callbacks. Again, one if it's successful, if the HTTP response is, if it's 200, if everything's okay, this is going to be invoked. If instead there's an error like 400 or 41 or 44 or whatever, right? It'll receive the error message right here. Right now, we're just printing it out to the console. Instead, what we should do is pass it to the view for rendering. So the controller uses the view model to pass the developers to the view for rendering, to the template, and it also passes the error, right? It'll pass one of them, right? If it's successful, this will happen. If it's unsuccessful, this will happen, right? And the view can then render either one, or the error from the model, or the developers, right? So the developers the error we can render as an alert. So for instance, we can use Bootstrap's alert div, right, in class, and render it if there is an error, right? So we can say ngIf, right? If there's an error, right? If there's an error, then I want to render it in red, right? And render the error object in there, right? Well, I can be more specific. I can style it a little better, right? This way it looks a little better, right? But right now I'm just going to dump the entire JSON error there, right? For debugging purposes. Otherwise, I have the developers, which I can render as a table, right? I can just iterate over all the developers and just print out the username for each one of the developers. Okay. All right. So now I want to be able to edit the developer. Right. Any questions so far? All right. So up to this point, I think we've covered this mostly. I did want to show you this from scratch. The editing a user. I created another view, the developer edit view. And right now it just has a header. And in the list view, what I did is that after the username, I added this glyphicon with an info sign, right, and a URL, right, that allowed me to navigate to the edit page, right. So developer/edit/ and then developer username, right. And that I navigate there, and that page is going to grab that username from the route params, right, and load the information for that particular user, right. So the edit view, I added a link so that you can navigate back to the developer. So this link here, which just goes back to /developer. When you click on developer edit username, right, we're going to navigate to that view, and I'm going to add a controller. That controller is my third controller, my third and last controller, right? 3 templates, 3 controllers. But the 3 controllers, they all live in here. They all live in the same JavaScript, developer.controller.js. And right now it's just this dummy edit developer controller. So 3 functions are in here, right? Each one for each template. We're going to retrieve the username from the parameter, right? So inside of the edit developer controller, I'm going to inject the route params so that we can read the user parameter, the username, and that username we're going to use it so that we're going to pass it to the service. So the controller, developer service, right, and pass it the username so that it can. We're going to call the find user by username so that it can go off and connect to the database to search for that user by username. I renamed find user to find developer. I thought it was a better name, find developer as opposed to find user. So I renamed the API. Okay, so we're going to send the request. So from the web service, we're going to send the request /API/developer, right, /the username. That's going to reach the web service. The web service is listening for this get, right, the user, right, from the database, right. So it's going to use the model. So let's see. We look up. The web service uses the developer model to find developer by username, and here's find developer by username. Again, notice the naming convention. They're all named the same thing everywhere, right? So that we understand that all these 3 or 4 function calls are all related to one another. So I am at the model now. I have the username, and now I can use Mongoose, right, to retrieve that particular record, right, that one unique record. Using the username as a predicate, right, and returns the developer, right? And okay, so we went all the way to the controller, to the service, to the web service, to the model, to the mongoose. Now we're going to work our way back, right? We're going to respond immediately with a deferred promise. The service is going to get ready for that promise with the then. The data model, if there's no error, is going to resolve the promise. The web service register function that's going to be called if the promise is resolved. The client, the client service returns its own promise, right, to the controller. Remember, there's two promises going on, right? One is the mongoose database, right, promising the web service, right? That's an asynchronous call. But from the controller to the service, that's also an asynchronous call, right? Because there's two networks that we have. There's two hops, two network hops, and so there's three processes running, right? The browser is its own process, Node.js is its own process, database is its own process, right? And there's two network connections in there. So we have there's three processes that we need to synchronize, right? All running on their own CPU, right? They're all running on their own thing, right? We need to synchronize all these three processes, and this is how you synchronize them, using these promises. So the controller too, since it receives a promise, it also registers a callback for a success, right? Just like the web service on the server side, it's registering a callback from the MongoDB callback, right? From the resolve. The controller too, on the client side, on the browser, it too registers with the client service that is also waiting for this get to come back, right? These two network connections. You see that, right? So I showed you the path, right? These thens, they're all connected to one another asynchronously. The other path, if there's an error, right? If there's an error, the mongoose model is we're going to reject, and when that happens, the web service also had registered a callback if there was an error, which sends the error back to the client, which sends it back to the controller, and the controller had registered an incoming error from the web service, right? And again, we can update either the UI with the developer object or with an error object. Notice that I use I use this name developer. I think that's a bad choice for that object, right? Because what we get back from the response is not the developer object, right? We get back a wrapper object, right? A response object, which inside of that response object there's a data, and that data object contains the developer data information. See that? So that's a bad choice for a variable name. That variable name is not the developer instance. The data is the developer instance. Okay, so a better name for this would have been just plain old response. Okay. So same thing. Error, if there's an error, or we're going to render the user, the developer, in a form, right? The developer form, username, email, first name, and last name. For updating, right? So we went from, fetch me a developer. Now we have the developer. Now update me a developer, right? And then come, right? So there's this ping pong, right? Of fetch me the user. Now I have the user. Okay, now I'm going to update the user. I'm going to send it back and post it back, and then it's going to come back, right? Hopefully, notice I'm trying to make these bigger chunks, right? So I don't bore you as much. Hopefully, am I boring you? Should I go a little faster? Skip over some of these? Yes? Is it too fast? Too slow? Is it just right? Yeah. Okay, yes. You have a question? Just right, okay. Yeah, because some of this already, I hope we covered last week, but it wasn't a think it was in the context of an application that was already existing. So I just wanted to give you a chance to see something that was created from scratch. Right? There's nothing, and from nothing we create something. Okay. Let's take a short break, and we'll come back and do update some more. All right. It's in Web App Maker in GitHub. Yes.
The assignment is done on the local client, but on the OpenShift it's not working. So I don't know what's in that. Unless it's something with the server, so cause a problem for evaluation.
Yeah. Well, no. I mean, we're always gonna evaluate by cloning and running it locally. Right.
But I need this for like.
Yes,
for interviews.
definitely by the end. At the end, definitely we want this to be running. You should look at the logs. And so search how to look in OpenShift using RHC, using the Red Hat command line.
Okay, so that I can do on my desktop?
No, it's from the command line.
I can do it in the terminal.
Yeah, in the terminal you say RHC logs or something, I forget what there's a command, and then they'll show you the logs and say where it's failing, what's wrong, and it's usually it's because you either forgot the package, you installed it locally, and you didn't do -- save. That's a very common thing that you forgot, or maybe you're using Q locally, but you never, it's not added to the
So
packages.
give me
It's a
proper
very
error.
common thing.
Like
Huh?
if I do the R, it's
Yeah.
not for OpenShift.
Yeah, if you do a push again, in the log, when it was running, when it was trying to push it, the error will be listed there. What's wrong, right? And probably you did a push and you didn't notice that it gave you an error. And that it
If
did
I
not
do a
restart.
second push, it doesn't get the error again.
Yes, yes, it should.
So I just did a push. I did not get anything else.
Did you,
Should I try doing something?
well, you need to commit something. Did you commit?
Yeah. But not in the server.
So version control terminal. So git status. Okay, there's nothing. So let's change something. Okay, so something changed, right? So git commit.
Oh, this is in relation to the GitHub.
What do you mean?
I thought we had to do first from the version controller and then do it. It's fine.
We are going to push.
Okay.
Right, so we're going to say, so now git, let me see, what do you have here? Remote origin. Okay, so we're going to push that. Who's the origin? Wait, remote. So origin, we have 3 origins. One to GitHub. And wait, how do you have 2 called origin pointing to different places?
Actually, to experiment, I've created another other server, but I've deleted it now.
Git push origin. Let me see. Where's it pushing that? Let me see where it pushes. Okay, that's pushing to the remote. Okay, stopping application, stop node application, blah, blah. We try, and then once it stops, it deploys, and then it's going to try and restart it.
Okay.
So if it can't restart, it should throw an error.
And if it restarts, it means that I can run it.
You should be able to run, yes. Mm-hmm.
3 quick questions.
Yep.
First is, I remember I told you that I had talked to you about the login thing in the assignment too, but at that time you just explained it on when you have to do it in assignment. And I told that you said that it's okay if you don't do it. You can do it for the next. And then you noted my last surname.
Oh yeah, I remember that. Yes.
So I believe the grades have come out that it hasn't made any difference. It's 97.
Okay.
But the only mistake is that you
login. Oh really?
Yes.
Okay. So yeah. So send me Piazza and I'll update.
Okay. Second question, for distance project, do we need to give the same implementation page or we need to do it differently? My module is differently, our module is different. Because I guess last time we were like, do we need to do the same project and mention on the page, top of the page that it's done by me or it's done by her? Or you want us to do different implementations?
Oh no. Both work in the same implementation, right? Yeah, no, both, yeah, the same implementation. Actually, you should be having the same.
So we can do some modules separately on the system integration.
Yeah. See, post receive fail. See. Error queue. So it failed, so it didn't start. Right, so we need to look at the logs. And yeah, look at the logs.
What's the name of your app?
Assignment.
For the assignment.
What's it called?
It's in Refactoring Spring.
It's not an application, this one. Oh, you need to log in to RHC.
Oh,
What was the last?
This is your login to OpenShift.
forgot.
Oh yeah.
Well, then you need to go to OpenShift and say you forgot
This
password.
will this expire?
No.
I'll do that in a minute.
Yeah.
Okay, this time we have implement sessions, right?
Yes. Yeah.
Thank you.
Thank you. All right. Let's continue. All right, let's continue here. So, what we went over is we have the username. The controller grabs that username, sends it to the service client, sends it to the web service, sends it to the database, comes back with the object, and then it gets rendered here in this form. Now we're going to add the capability of updating the developer. To do that. We're going to add a new hyperlink on the right-hand side. We're going to pull it right, and we're going to add it OK. And we're going to notify the controller if we that we are calling update developer. On the controller side, we're going to add an event handler. Again, following John Pappas' style guide, we declare all event handlers at the top, right, and then we implement it down at the bottom. So here's the event handler update developer. And the update developer is going to use the service, right? So the service, so the controller is going to inject the well, it already has the developer service because it used it to fetch the developer by username, right? So we already injected it. But now we're going to use it in the event handler to go and update developer. We're going to pass the developer as an object. The service client is going to declare an API that we're going to call to pass to the developer, right? Again, we're connecting the controller to the service client. Next, we'll connect the service client to the web service, and blah, 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 right? We're working our way from left to right, and then we're going to work our way from right to left back. Yes. We send the update to the service client, right? Is going to send a put. Notice that we're using put, right? All the URLs are more or less the same, right? /API developer, right? And we get, when we want to read, we use get with the username like this, but we want to modify, we use put, right? And we pass the developer, which is going to be added to the body. On the server side, we listen in for that incoming put, and we declare a handler that handles that HTTP events with that URL pattern. Then the service client, the web server, retrieves the username and the body from the HTTP world, and it converts them into objects again, right? That's the responsibility of the web service, right? To bridge these two worlds, the HTTP world with the object world. And once we have the username and the object, we're going to use the model, right? We're going to use the web service is going to use the data model, the developer model, and call update server on it, a developer on it, and going to pass it the username and password and the developer object. The model declares the API, right, and is ready to receive that data. It actually updates it using the Mongoose model, using a function called update. So this is the Mongoose model that has all sorts of low-level API to talk to the Mongo database, right? One of them is .update. .update is a combination of find me the object and then saving the object, right? So this dot update is a combination of those two functions. One is find one, well, find, it could be more than one, it could be sort of find me, and then change them, right? To do that, it has two clauses. One is the predicate, right, that identifies all the documents that need to be updated, right? Which ones do we want to update? Those whose property, username property, is equal to the username parameter that we're passing as an argument, right? So this is a filter, right? It filters those documents that meet this criteria. It might be just one, it might be none, right? It might be a whole bunch of them, right? But first, there's an identifying. This is very much like in SQL, right? In SQL, we do the same thing. We do an update, a particular table where, and then we provided some kind of predicate, right? If you don't provide the predicate, then you update all the records, right? Same thing here. We provide a predicate to identify the subset of the records that we want to modify. After that, we provide those fields that we want to change. And we provide the new values that we want to set them to. Okay? To do that, we use the command $set. $set is one of many commands, Mongoose commands, that map to MongoDB commands. Right? MongoDB has a whole bunch of commands. They all start with $. Right? So you understand that these are not variables. These are commands to the database. And the set command does what you would expect it to do, right? It changes the values of fields that are named in this object, in the developer object. Right? Developer is an object, right? What fields are in the developer object? _ID, username, password, first name, last name, right? So that's an object. It's a name-value pair a collection. It's a collection of name-value pairs, right? Not all of them need to be there. So, you can have a subset of the fields, not all the fields. In here, we're doing a blanket update of all the fields, right? But to only modify those fields that have changed, right? If a field is not changing, it has the original value and it has this new value. If it hasn't changed, it's not going to bother changing it, right? So it's going to ignore those fields that are not changing. Instead, it's going to update those that do change. Okay. So here we kind of got a little lazy. We just passed the entire developer object. We could be more granular, right? And just provide a subset, right? Provide a smaller object that has maybe just one field. Say we want to change just the password, right? Because we forgot the password and we want to, we reset our password and now we want to change our password, right? In that case, we would maybe provide a smaller object here that contains a single field password and the new password. Make sense, right? So you could be as granular as you want, or it could be as wide as you want. This could be an object that contains other objects, right? This could be a fairly complex object, right, that contains other nested objects, nested objects, nested objects. As it meets the schema, right? This object, when it gets updated, is going to be validated against the schema, the correct field names, the correct data types, those fields, if they contain subfields, right, and contain sub-schemas, then those as well are validated. Okay. Right now it's just JSON object, a plain JavaScript JSON object. Well, are those POJOs as well? Are those also referred to as POJOs? In Java, they're referred to as plain Java objects, POJOs. But I wonder if JavaScript are also referred to as POJOs. Anybody know? No? Okay, so we've updated in the database. The database needs to respond with a promise. And I'm boring you with this, that you've seen this quite a few times already. Returns a deferred, the web server receive it. If there is no error, it's going to resolve it, and it's going to call this function call on the web server, the web service. It's going to return that promise in the client, and the controller is going to receive that successful function. Yes, you've seen this enough times. If it fails and it gets rejected, right, the web service is going to also send, going to call this error function. It's going to send back an error status and the error object, and the controller is going to receive it here as an error. Okay. The controller, when it does receive a successful response, it's going to navigate programmatically to the developer. I'm done. I updated. Right. I'm done. I'm going to navigate to the list of developers with this developer having been updated already, or otherwise I'm going to stay in the same page. I'm not going to go from the edit page, and instead I'm going to highlight the error that occurred. The update object, the update page, not only does it allow me to update in place, right, and change my first name, last name, phones, and whatnot, it also has a delete button at the bottom, right, that if I click on it, it should remove this particular record and then go back to the list of developers minus that developer that has been removed. So from the view, I'm going to add at the bottom, I'm going to add a red delete button, right, that is going to notify the controller that to remove this particular developer that is currently being rendered. The controller is going to declare an event handler for that delete, right, and it's going to implement it down below. It's going to notify the service, right? The controller. Where's the controller? The controller is going to use the developer service. Is going to invoke this controller is fairly complex. It uses 3 web service calls, right? One to find the user by username, right, or the developer by username. One for updating the username, the user by username, right? And the other one for removing. So it uses 3 web service calls. So it's getting fairly complex, right? This might be a good argument for having the controller be its own file, right? It's typically the rule of thumb, if it's something bigger than a page, then you should consider having it being its own file. So here we have the delete developer calls the web service, the client service, which we declare here, and it's implemented over here. Then the client server is going to notify the web service, right? So here's a client service doing a .http.delete, right? Using /API/developer and then the username. It doesn't pass any data, right? The only data is the username that we want to remove. The web service is going to listen for that incoming delete, right? For that URL pattern, and it's going to invoke the event handler for that delete. Okay. Right. Notice the pattern. Right. Notice the URL patterns. Right. That they're all the same. Right. That they're being distinguished by the puts and the gets and the posts. Right. This is what we refer to as a RESTful API. Right. That it follows this nomenclature. Right. Of using these different HTTP actions or verbs. Right. To implement different actions on the data model. Right. So, and then the web service finally is going to use the developer model to call the delete developer and pass the username by which we want to identify that developer. The model is declares the delete developer function, right? And in here we're going to put the mongoose, low-level mongoose interaction to actually remove the developer. To remove the developer, the mongoose model, the low-level mongoose model is going to use a new function, right? Is the remove function. The remove function right? Like the create and the find and the find one and the update is one of several low-level functions that allow it to interact with the database. In this case, remove does what you would expect, right? It removes the document, right? And it needs a predicate. It needs a predicate, right? Saying, well, which one do you want to remove? You want to remove all of them, right? By default, it does not remove all of them. If you do not provide a predicate, it does not remove all of them, unlike SQL, right? In SQL, if you don't provide a predicate, the default interpretation is that you want to remove all the records, right? Here, the interpretation is that you don't want to remove any record, right? I don't have anything that matches your predicate, so I'm not removing anything, right? So it's a little safer, right? So you have to provide a predicate, meaning identify for me all the documents whose username property argument passed in through the function, right? That matches this attribute. Once a document has been identified, remove it, right? Remove it. And then the callback, right? Remember, all these are all asynchronous. So again, the promise, right? So the model returns a promise. The web service listens for that incoming promise. The model resolves that promise, and the web service receives the call here, and the client returns that promise, and the controller receives that successful promise over here. If it rejects it, if the model rejects it, the web service receives calls the error function. The controller receives it here and passes the error to the client, to the template for rendering. If it's successful, if the controller was able to successfully remove the object, right, and it receives a function call here, is going to navigate to developer. Now, I didn't see what the web service returned if it was successful. Notice that the web service, if it's successful, the only thing that it's returning is a 200. See that? It's not returning any data. It's saying that it was okay, everything's okay, I was able to remove it. Or otherwise, I'll return an error object. It's a JSON object with its own status and whatnot. But here, there's no need for the web service to return any data if it's successful, because the page, right, was representing an object that no longer exists. There's nothing to display for that object, right? So there's no, you don't. Instead, I'm going to navigate to the previous page where there was a list of all the developers, but that page will come back for all the developers, right? And we'll render that list of developers, right? So yeah, so I just wanted to make sure that I wasn't returning anything, and this navigates to the list of all the developers if it was successful. All right, great. So let's move on now to the next entity, right? So we're all done with developers, right? We created all the CRUD operations using those 3 templates, right? Using those 3 controllers. One of them implementing delete, list, get one, right? Get me one by username, and the other one was updates. One template was implementing 3 of the CRUD operations, right? Yes.
So in update, we are uniquely identifying the document using username.
Yes, and passing the object.
Yeah. So what if the user, while updating, uses a username which is already existing in the data? It's a link conflict.
Yeah. So typically, what you want to do is enforce uniqueness, right? So for instance, in the schema, you can configure that a particular field is unique.
In this case,
right? In this case, it would be unique. So, for instance, if you try to do that, right, and change your username to something that is already taken, right, it will first check to see if the username is unique. If it is, it will go ahead and change the username. Otherwise, you'll get an error from the database, right? And the error will travel back to the controller, and you'll get a big error message from the controller that you're trying to violate unique properties, right?
So is it wise to update it using username, or we can go with ID also? I mean, ID will be
Right. So the other thing that we need to consider is that be able to change your username, right? So we should not even let you change username. So one of the ways is that we're going to say that it's unique, right? So definitely we're going to make sure that that the database validates this for us, right? And we'll throw an error, right? The other thing is that what we should enforce at the application level when we update, when we update a username, when we update an object or an entity, to remove anything from the object that we don't want that makes it to the database, right? So for instance, we would say delete developer.username, right? So even if you pass us an object with whatever username you want to pass us, right, we are going to ignore it. So for us to ignore the username field, right? Only in creation, right, I would take your username. Well, that means that we're going to validate it against uniqueness, right? And we're going to give you an error if the username is not unique. But after having created, we're going to disallow changing that username, right? And we're going to enforce that at the application level, right? The application level in the update developer in the web service, right? In the web service, we're going to take the developer object. If you remember, that's going to be passed to the model, right? Right. Well, actually we could enforce it in either place. We can enforce it at the web service level. We can remove the field username, so it never actually makes it even to the model. Right. So the model never sees the username. Right. So it never gets updated. Right. Perhaps in the update, we might decide that password also should not be updated here. There should be a particular process by which password gets updated, right? Not through the regular updates. There should be maybe a dedicated, forgot my password or change password, other web service to do that. So you can be as granular as you want, right? Right.
Where was I?
Right. So we did all the CRUD operations for the developer. Let's move on to the next to the next entity. Right. One developer has many applications. Right. And our API, right, and our URLs should reflect the fact that we have this relationship between these entities. Right. So there's you have a username, and then one user has many applications. Right. And that application might have many pages, and that page might have many widgets, right? So that association of these different entities should be reflected in the state, right? In the URL and also the URL of the API, right? So that a unique URL pattern always identifies a unique element in your data model. Okay. So here we're creating. When you navigate from a, notice that we navigate to the applications of that developer, right? And notice the URL. The URL pattern is that we have developer, username, and then application. Okay. Now, so what we're going to do is that we're gonna create a template that renders all the applications for a particular user, right? And the URL that we're going to use is the developer username application, okay, which we just navigated. And right now the view is just going to be just the template is just going to be a header with application just at the top, a title. In the list of the templates. Oh, okay. I'm sorry. Here, right? The list in each one of these usernames. We're going to make a hyperlink out of each one of them, right? So that if you hover, you'll notice that the template, the pattern is /developer/username and then /application. They all have that pattern, right? That navigates to the applications of that particular username, right? None of these have applications, so only genuine applications. Okay. Right, so to do that, we're going to go back to the list of developers, and we're going to refactor this. Instead of just displaying the username, we're going to make a hyperlink out of that username. Right? So we're going to wrap the username with a hyperlink that is based on the username of the developer. See that? Developer username. Yes?
So does that have to be ng-href, or I feel like I came across.
If it's an image, yes. If it's a reference, it doesn't need to be.
That's right.
If it's an image, you need it because the browser will immediately start to download that image, right? Even if the DOM doesn't actually have that.
It's for something dynamic.
You could wait a couple milliseconds for it to be rendered, unless you're very fast and try to hit it before Angular gets to it and renders it. Yeah. Yeah. So this is linking to that application list of applications, which right now was just displaying that title. From that page, listen, right? I'm going to add a hyperlink that allows me to navigate back to the list of developers. Lets me go back, right? So it's linking to /developer. Notice that I'm trying to follow the same nomenclature that we use for the RESTful calls, right? Although in the RESTful calls we have put and delete and get, right, to be able to understand the meaning of each one of the URLs. In here, hrefs, the only thing that they are is they are only gets, right? As you navigate in the browser and you change the URL, those are all gets, right? So you'll see me, when we go to it or edit a user, you'll see me add to the URL, right? The intended action that we want to do about that particular entity instance, right? So right now, /developer, like the API, right? The understanding is that you want the entire list of the developers, right? So this navigates to the list of developers. All right, so we want to go fetch the list of applications or create a new application. So we're going to need controllers for that, right? So in the list of applications, we're going to add a new controller. We're going to load that controller, and in that controller, we're going to have this is a boilerplate file for a controller, declaring a single controller for this controller. But I'm going to follow the same pattern I did for the developers, right? Again, there's going to be 3 templates. It's going to be 3 controllers, but those 3 controllers are going to live in one single JavaScript file. Okay. So here's application list controller, my first controller. From this application controller, I'm going to add. I already have the back button, right, that navigates back to developers. I'm going to add this plus button that allows me to navigate to add a new application, right? And notice that the distinction here is that developer genuinely application, right? This says in RESTful terms, it means that I want all the applications, right? So I'm matching the URL in the view, right? Also with the URL that I'm going to use later for asking the web service for the list of all the applications. I haven't done that yet, right? But if I want to create a new one, to distinguish this, a user that doesn't yet exist, notice I use this /new, right? /new, meaning I don't have an ID for this because it doesn't exist, right? So the way I distinguish this from an actual user or an application is that I use the keyword new, right? So there it is. So this navigates me to the application new view. And here's the plus sign that I added to the list of application, which navigates me to the new page. And here's a new page. The new page is just, right now, it's just a title. Now, for this hyperlink to work, it needs the username, right? It needs the username. And the only way to get it added is through route params, right? We've navigated to this page using the username, and so we can grab that from the route params and just feed it, feed it back to the view so that it can render that URL, okay, with the plus sign, okay. Right. So in the new application controller, we're going to create a new application controller so that listening for an incoming event handler if they click on a new if they click on a save or they have type values for that new application, right? So here's the new application control. Is the application control that we're going to use here for this page, right? In that page, we're gonna add a cancel button so we can go back, right? So we can go back to the list of applications, right? So we can always navigate between these two, right, back and forth, right? So let's add the cancel. So basically, it's I'm gonna add at the top an arrow back, right? Needs to go back to the application for the current user, right? The current user. So the only place that I have that is in the route params, right? That was passed to me when you navigated here. So for that, I'm going to need a controller, dedicated controller, for my new application that grabs the username from the URL and feeds it to the view, right? So template, I create a new application controller. Again, the only thing that it's doing is just grabbing that username and feeding it to the UI, right, to the template, so that it can navigate back to the parent. Okay. All right. So, okay. So we're going to add. Over here, we're going to add this button on the right-hand side, right? So that when I type the information about the new application, when I click on it, I'm going to notify the controller, right, that this is the new information for the new application, right? So on the view, on the template, I add the button on the right-hand side, right, with the OK check mark, plus the input fields for the name of the application, a description for the application. This could have been a text area instead of an input, would have been a better choice. If I click on the OK button, it's going to notify the controller create application, going to pass the application model. The controller is going to be notified. Here's right for the create application. And it, in turn, is going to notify the service, the application. This is a brand new service, right? That its purpose is to talk to the web service, right? So I create a new application service on the client, which I call application service, and it declares a single create application that is going to be called by the controller. Right, so the controller, when I click on the OK button, it uses the application service and it passes it the application that it wants to create. The service is going to create a post, right? The service is going to create a post. Let's see. Yeah, so the service in the create application is going to create a post. Send. It's going to use an API, a RESTful API, right? / developer. Particular developer is going to create a brand new application within that developer, right? My RESTful URL captures the relationship between developer and application, right? Where application is one of many inside of the developer, right? And it passes the application. The client, the web service client on the server listens for that incoming post, again following a RESTful URL pattern, and declares an event handler for that HTTP post. We have forgotten about that, right? The app.js had only declared models and services only for the developer. Now we have a brand new service, right? We have the application service, right? The application web service needs to declare endpoints for the CRUD operations for manipulating the applications, right? Even though, right, the RESTful service, right, has relationships with the username, right, and the developer, but it's being declared in a separate web service endpoint, right? Right. So we declare the new application service in that's and we pass it the Express app so that it can create its own endpoints. So now in the web service, we retrieve the HTTP data, right, the username for which we're creating the new application, and also we retrieve the application object from the body. Now that we have that, we need a schema, a model, right, to store this in the database, right? So we create a schema for the application, and we say that application is going to have a foreign key. It's going to have a reference to the parents that, or the owner of this application, the developer who developed this application is going to have an object. It's going to have the ID of the object. Oh, I'm sorry. No, it's going to use a username. Sorry, it's going to use a username to know who created this this application. Later on, if we want to create a many-to-many relationship, we're going to have to revisit this, right? We're going to have to revisit this, and instead remove this relationship, and instead of having like a mapping table or mapping a collection, right, that associates users or developers with many developers associated with many applications. So we could come back later on and refactor. Right now, we're going to keep it simple. The application just knows who its parent developer is. We're going to use this to join, not really join, but retrieve those applications. Once we know who the username is, right, we can always retrieve the applications for that particular developer, right? It's not a real join. Then we declare a name property for the application, and notice that instead of just declaring as strings like we are doing for all the other properties, notice that we are using an object to configure the property, right? The property can be configured. If it's just a type, if you're only providing the type, then you can use this. You can use this syntax, right? Just the property, right, and the data type. But if you want to configure other things other than just the data type, right, you can alternatively pass an object. Yes, pass an object, and that object, definitely you have to tell it what is the data type, right? And if that's the only thing that you're configuring, might as well use this syntax. If you're just configuring the data type, we might as well just use this syntax. But if you want to configure other things, such as whether it's unique, right, default values, right, you can provide other things here. You can say default. The default value, right? If you don't provide a name for the application, I will default the name of this application as just application name. Okay, that's a default value if you do not provide a name. Right? Description is just a string and now I'm going to keep track of timestamp, right? Of when was this application created. So for instance, I can create a date created. When was it created? So the type is date, but the default value is date.now. Right? This is a unit, right, of when this record was when this was created. So date.now will include the wherever the server is being hosted. Careful, the server might be hosted in California, or it might be hosted across in some other country, right? So the timestamp will be wherever that server is running. Okay, so wait a minute, I just created it, and why is this 3 hours earlier, or why is this 3 hours later, right? So be careful of where this is being created, right?
Also notice that we are creating the collection, right? That the name of the collection is application, right? Now that we have the schema, we can start working on the application model, right? We create the model, right, in the application model, and it loads the mongoose, it loads the schema, and it creates an application model. This is the low-level mongoose model, right, that it will use to interact with the database. Yes? But application model, that server, is going to provide the high-level API to the rest of the application. Okay? One uses the low level, right? This is the low level, and that's the high level. Okay? All right. Okay, so I'm going to pass the application. Wait a minute. All right, so on the app.js, in the app.js, we had only created the service. We only had created the service up to this point, right? But now it is a service who's responsible to passing along the data to the model so that the model can actually store in the database or retrieve things from the database. So we're going to instantiate the model in the app.js, right, by loading the application model server. And we're going to pass it to the service, to the web service, so that it can interact with the database through the model. Okay, so now the model, the application model, once it receives the instance of the application object, right, it uses .create, right? .create, it does the insert into the database, right? But it's going to return a promise. Returns. And this is pretty much the same as earlier. Actually, not quite. So it returns a promise. The web service returns, accepts the then, and here's the full implementation. I implemented the whole thing, so I'm not gonna bore you again, going back and forth between the promise and whatnot. Right? Here's the whole implementation. The data model, it just returns, rejects or resolves. The web service registers the two functions. The web client service returns the posts, and then the controller just receives the data from the server. Okay. If the application was successfully created, we're going to use location URL to navigate to the list of all the applications, right? Okay, so now that we're back in the list of applications, we need to query for the list for all the applications, not including the one that was just added. So to do that, the controller on load, right, it's going to call init, and it's going to call find application for username, right, having extracted the username from the route parameters, right, and the service is going to take that username. The service is going to take that username and is going to send a GET request all of the applications. The web service receives that request, right, and responds. Well, not yet responds, right? Just retrieves the username from the path parameter. The web service uses the application model to find the application for username, right? So it creates a find application for username, which is going to use to retrieve it from the application mongoose model. So here's the implementation for the model. Just find, right? Using that predicate, right? Developer username equal username. So it only retrieves that one application, right? Actually, this should have been. Oh no, that's fine, right? Because there could be many.
applications, right? There could be a whole bunch of applications. So this should not be find one, right? Because that'd be many, many applications that were created by the same developer. Return promise, I'm not going to bore you. Returns, blah, blah, blah. I'm going to skip over that. Returns promise, response to the client, provides application to the view. Rejects, I'm not going to bore you. Render the error, render applications. Okay, so finally the controller receives the application, right, and it renders it as a table of applications. Okay? All right. Add, edit, cancel. I really want to get to the using the new API to web service, declared, query, database verification, refactor to use. Okay, there it is. Okay, so now we're going to refactor a couple things in the data model, right? So that instead of using these queue promises, right, from Mongoose 4x and on, right, it supports promises natively. So we don't have to use a queue promise, right? And so we can refactor. So instead of having this callback syntax that we've been using so far, right, we can refactor it and pretty much use the same way that we've been using in the web service, returning, right, the promise right away instead of having a callback. So let's refactor some of this, right? So let's start here. So we had started with find application by ID. We want to be able to retrieve an application by ID, right? And everywhere else we were using these defer, right? And then rejecting or resolving, reject, resolve, reject, resolve. So let's use instead, let's use the new promises API. Okay, so we implemented that. And I was starting to implement it using the callback, right? I was starting to implement it using the callback like we've done all along, right? But instead, we're going to remove all that. We're going to remove all that, and we're going to return it. We're going to say return application.findById application ID, right? It almost looks like what we would expect, right? It's a function. It does what it needs to do. It does its thing, and then returns, right? So that's one of the beauties of using the promise API. Right? It looks as if this were synchronous, right? But unfortunately, it doesn't return the array or it doesn't return the application. It doesn't return the application object matched by the application ID. Instead, this is going to return a promise. Okay, but notice how cleaner it is, right? Notice how cleaner it is, right? Instead of having to declare the queue, right, and reject and resolve and then return the promise, notice how much cleaner it is. We just return, right? The web service stays the same. The web service stays the same. It receives a promise, but instead of us deliberately creating the promise, back the promise, and rejecting and resolving, right? All that is included and done for us by the native implementation of the promise internally. Okay, it's basically delegating that work to the service. The service is going to receive the promise and do what it needs to do. Did we do this? Okay, so now the web service, it does what it used to do. Right? From the service point of view, nothing has changed. It was always receiving a promise, right? But before, it was us, deliberately creating and using this queue promise. But now, version 4.0 and newer versions of Mongoose support promises from natively. Everything else stays the same. Everything else stays the same. So I'm not going to bore you there. We render the application in the edit view, right? So in the edit view, we just render it. Nothing new there. Handle error. Okay, let's implement the remove. So the remove, it's on the client, it's going to have a
we're going to add a button. You have a question? You have a question? We're gonna add a button to notify the controller that we want to remove this. The controller is going to delegate that to the service, right? The service is going to send is going to send a delete. So here's the implementation. The client service is going to send an HTTP delete, right? The web service is going to receive that. There it is, delete. It's going to receive the delete, which is going to be right here, the remove application, right? It's going to extract the ID of the application that we want to remove, and it's going to call remove application, and it's going to still expect a promise, right? But notice that in the data model, the remove is so much easier. Right, we don't have to use the queue library to create the promise. We don't have to reject. We don't have to resolve. Also notice this new syntax we're using here. Right, so Mongoose, instead of using the syntax of providing a predicate to the remove, remember when we did a developer and we were removing the developer. In the syntax that we use there, we pass a predicate to the remove function. Remember that? Okay. Well, this is a syntax that has become fairly popular, right? That makes it look like your string of transformations, right? They're being piped one to another, so that each transformation filters even further more and more predicates on the original application, on the original operation. So this remove, right, can be chained with other functions, right, that can allow you to almost write it as if it were a sentence. Remove where it's equal to, right?
So in
Yes.
case of developer, it will be where username.
Exactly. Yeah. Right. So in this case is from the application, I want to remove where the ID is equal to application ID, and there's a whole bunch of these functions. There's not equals, there's less than, there's greater than. There's a whole bunch of operations that you can do. Right. And it's returning a promise. See that? It returns a promise. The web service is expecting a promise, so that doesn't change, right? So that is the same. It's just that I'm showing you just a new way on the database side, right? So once the application has been removed, we navigate back to the list of applications. So I'm not going to show you that. Can I have a name? Okay, so we're going to navigate now to the list of pages. Right. Once we have the applications, we want to navigate to the list of pages. So we're gonna make out of the list of the URL out of the names of the application. We're gonna make a URL out of them, right? And the URL looks something like this, right? If we click on it and if you hover over it, notice the URL. The URL, it's a RESTful URL, right? It says developer and then the unique identifier, application, and then the unique identifier, and page. So the pattern is entity, identifier, entity, identifier, entity, right? And this URL pattern follows, right, the relationship between all these entities, right? That there's a parent-child relationship between these entities. There's a one-to-many relationship between these entities. You understand, right? If we had many-to-many relationships, then these URLs could go the other way, right? So for instance, if there's a one-to-many between developer and application, right? Then the relationship is only from developer. You can go from a developer, you have the ID of the developer, and then the application, right? But if you had a many-to-many, you should be able to navigate the other way around, right?
a particular application, I can have, see that? So that the both would be RESTful URLs, but navigated from different endpoints. See that? Right? Both would be legitimate. Right? But our current implementation is that there's only a one-to-many. From a developer, I can navigate to an application. All right? Make sense? So the URL should follow this this particular order. Okay, so when we navigate there, we have a controller that fetches the applications, the pages. I don't know which one. Okay, this one. And I'm not gonna bore you. Click on back button. That's the same. Add button. Navigate to a new page. Click on back button. Okay, so that's you can look at that on your own. Click on add page button to add a new page. Create page event. Delegates to the page service. Web service model. Add create page in the page model. So in the page model. Oh wait, do we have a schema? Did I skip the schema? No, I have it. Okay, right here. Okay, so we're in the page model, and the page model, we have a create page, right? We're going to create a page, and the web service uses the page model to create a page for the parent application ID. For the parent application ID. Okay, let's look at the schema. So this is hinting at the fact that pages know who their parents are, right? That's a classical way of implementing this, right? Where you have the developers are the owners of applications. So typically, the way we implement it is that the application has some kind of reference back to the parents, right? That's the legacy. That's the typical way that we've implemented things in relational databases, right? Children know about their parents, right? Over here, we're going to take a different way of implementing. First, let's implement the page schema. So the page schema is going to be right here. This page schema is going to have a name for the page, right? It's going to have a title, maybe the title that renders at the top of the window, right? It has also a timestamp when it was created. So this is the schema, right? But instead of it living in its own collection, like developers are living in its own collections, like applications are living in their own collections, instead of doing that, we are going to embed these pages. We're going to have that a page, right, only has meaning inside of an application, right? Now this is a profound decision. But what we're saying here is that pages only exist inside of applications, right? This is an implementation of a what do you call it? Wait a minute. It's a when the life cycle of the children composition. Thank you. When you have a children, the life cycle of a child is completely determined, right? Meaning that when the parent ceases to exist, right, the deletion of the parent cascades to the deletion of the children. Now, in relational databases, the way we implement composition is by cascade deletes, right? It says if the parent is deleted, we cascade that delete to all the children's, right? So any child that has a reference back to the parent, all those are removed as well, right? The way we implement it is by embedding the schema inside of the parent. If the parent JSON object ceases to exist, any data inside of that JSON object, including the pages, also cease to exist, right? So that's one thing that we're deciding. Another decision of embedding this in here is that presumably pages are not shareable, right? That the instance of this page only exists inside, all the data for the page only exists inside of the parent application, right? As opposed to applications, for instance, being shared by many developers, where many developers are associated with many applications, right? In that case, we use a many-to-many, and we have some way of navigating by using some kind of mapping table, right? Over here, we're deliberately putting pages inside of an application, and that, for instance, would stop us from implementing use cases such as a page declared application could be reusable by some other application, right? It can't, right? Because it only lives inside of this application, right? Well, one way that could be implemented is that we do a copy, right? Copy the page from one application, and maybe we push it inside of the pages of some other application. We would not be sharing, right? We're not sharing that page, but we have a copy of that page, right? Or we don't have a reference to the page, we have a copy. All right, so yeah, so it depends. It depends. This decision has to be driven by the use cases. If there is no use, then this is a completely legitimate solution. But if there is a use case where pages might be reused by different applications, then this would be not the right way to implement it, right? It would be better to have its own collection of pages that are shared amongst applications. See that? So the data model should be driven by use cases. All right, so page schemas, okay? So the all right, so if we want to add a page, right? So if we want to add a page, okay, we want to add a page, then we need to. So now, whenever we want to manipulate the list of pages, we're first going to have to fetch the application, right? Fetch the application. We look at the array of pages, and then we either push into that page, right? And then we save the entire application back into the database, right? So now in MongoDB, the preferred way of implementing schemas is this way, right? To whenever possible embed. Okay, MongoDB does a lot of optimizations, right, for indexing and using blobs to make this small and compressed data to have very efficient JSON representations of this data, right? With the understanding, specifically for schemas that are inside of schemas, it works very well with full, very full-blown JSON objects, right? As opposed to things referencing each other. This is a document database. It's not a relational database, right? A relational database is optimized for references, right? Documents are referencing other. Records are referencing other records, referencing other records. And the way it organizes itself using binary trees and hash tables and indexes and so on and so forth are optimized for this kind of references, right? In document databases, right, it's a complete different way of thinking things, right? It's a full-blown document, right? Objects, including arrays, including other objects, including arrays, including other objects, right? It's optimized for that, right? It's not optimized for references, right? Even though it does support references as well. Okay, make sense? All right. Yeah, so whenever possible, right, when the use cases don't force you otherwise, right, embed the schemas, right, have full-blown objects. Okay, so inside of the application model, there's an instance of the model, and because I wanted to be able to use that application model in other places, right? I added a get mongoose model, right, for the mongoose representation that is the low-level application mongoose model that is being used to talk to the database, because I want to use it in other places. Okay. Let's see. In the page model server, okay. So in the page model, I want to implement the create page, right? So to create the page, I know the parent application ID. We have the page object that we want to create. I'm going to use the low-level application model to fetch the application. Okay, now I have the application. Once I have the application,
I can now start pushing the new page object onto that application, which I didn't do. I think it's the next one. Okay, so we're going to add in the page model. Okay, in the page model, this is the find application. There it is. I find the application. Notice that I find the application. What does that return? It returns a promise, right? That is going to retrieve the application object, right? The entire application. So I'm gonna inside of the model. I am ready for that promise, right? And it's gonna pass me the application. Now I have the application, and that application has an array of pages. Yes? And now I have the pages. I'm going to push the new page object that was passed to me, and since I have modified the application object, I'm going to save it back to the database, right? Because I have modified the application object, and I save it so that it gets updated into the database, right? Right, and here it is. That's the application.save. And what does that do? That too returns a promise. Right? It's a promise within a promise. Right? Eventually, the web service receives the response, right? And we can return the full-blown application object. Click on back button, after creating a page, navigate, list the applications, page list view, render, navigate the page. All right, I think I'm gonna leave it here. But as you can see, the new version of Mongoose now fully supports promises. It has an extensive list of functions that allow you to interact with the data model using almost like a phrase. You can like a structured query language almost, right? If you're using these functions, you can more or less use the same kind of syntax that you were perhaps familiar with in relational databases, and provides you this more familiar way to interact with the low-level database. All right, any questions? No. So how do you find these snippets of code? Are they useful? Are they small enough? Are they too small? Are they? I just want some feedback on whether it's this format of showing it. It's almost slides, right? Almost like slides, but I just wanted some feedback. Is this working for you? Yes. Okay, great. Thank you. All right, I'm going to stay a little longer if you wanted to chat.